1001, 1001. Grid illumination. On an n by n grid of cells, each cell xy is with x between 0 and n and y between 0 and n has a lamp. Initially, some number of lamps are on. Lamp sub I tells us the location of the ith lamp that is on. Each lamp that is on illuminates every square on its x, y, and both diagonals, similar to a queen in chess. For the ith query, query sub I is equal to x, y, the answer to the query is 1 if the cell is on L0. After each query, we turn off any lamps that at cell XY or 8 or adjacent 8 directionally. Return an array of answers. Each while you answer by should you go to the answer of the I queries sub I. Okay, let's look at some examples. I mean, I get it conceptually, but let's kind of look. Oh yeah, is that how that works? I don't know anything about Leetcode, but cool. So n is equal to 5. You have this lamps at so before performing both lamps and 0 and for 4, the grid represented cell is lit like this. How does things get lit again? X, Y, and both diagonals. Okay, like a queen. Okay. What is n? Oh, 20. Oh, n is 10 to the 9th. Wow, so you can't just simulate it, which would be a much easier form. Okay. And then the query at 1 sub 1 returns 1 because the cell is lit. 0, 1, 1. And after this query, the lamp at 0, 0 turns off. After this query, oh, so then this cell turns off. Before performing the second query, only the second lamp is off. So now the query turns 0 because that cell is no longer lit. How sad. How do you turn off again? We turn on the lamps that are at cell. Okay, or nearby. Okay. Let me think about this for a second. I don't have an immediate obvious answer. Oh, my chair. Okay. Okay. On the second query, we're gonna have lamp X. So yeah. So I have to keep track of. Oh, n is not lamps. N, what's n? Oh, n is the what is the boundary? And lamps is the 20,000 lamps. Okay. So we just have to keep track of them, and then one is so obviously the naive. Okay, but so the naive algorithm is just having what you may call it. Yeah, just naive algorithm is just do an n squared type algorithm, which is going to be way too slow. That's like what 400 million. Yeah, that's going to be too slow to run. So okay, so what does this mean again? So what we think about when we see lamps is that we keep so I think what we want is a sort of binary search tree type thing, where you do it on the x, you do it on the y, and maybe even the diagonal, and then kind of figure it out. But because then you could do every request in log n, and then that is straightforward. And then also the query with what we call it, remove lamps, and then with a self-balancing binary search tree, then that's trivial, right? So, but what I'm thinking right now, to be honest, is just that I'm trying to figure out a way to be lazy in terms of implementation. So I'm not gonna write a binary search tree. So what is a way to do stuff that is the search tree like thing? Is there a in Python, and because I know in C++, maybe I should do in C++, but Python set, does it have binary search or lower bound or whatever it's called? Is it called lower bound? I think there's the bisect, but does bisect work on a set? What? You and your Cartesian trees. I guess not. Maybe I should do it in C++ because they have their thing. Yeah, I just have to do it once. I think I try to be very no copy and paste when I do these things. But yeah. Yeah, I guess it's in C++, so maybe I'll do it in C++. Okay. Yeah, maybe one day I'll look into it. I'll add it to my to-do list. But yeah, just so now I'm going to focus on kind of pre-processing the lamb so that we get whatchamacallit. So we could do lookups in of log n. But basically we have 4 directions to cache, which is the vertical, horizontal, and then the 2 diagonals that gets lit. I think that's right. And you could kind of think about just and you just have to think about how to label your diagonal so that's consistent, which I usually say is yeah. So how do I mean, it's not hard to draw the thing to see if it's lit, but yeah, because then let's just say you have 4 sets, and then int, let's just call them horizontal, vertical, horizontal, diagonal 1, diagonal 2, and then for auto lamp and lamps, and then it's as long as we're consistent, it doesn't matter which one's the x and which one's the y. But yeah, vertical dot insert lamp of 0, horizontal dot insert lamp sub 1, and then now the diagonal 1 is insert lamp dot 1. Do I have this right? I feel like I get a little bit confused about labeling them. I think this is roughly right there. Well, and then now for auto query and queries, oops, too many language mixing. Now if vertical dot find query sub 0, then this is true. What are our results? Returns 1. So okay, so let's just have a boolean. Found is equal to 0. I know it's supposed to be false, fine. But let's just do found is equal to 0, just because that's where we're pushing back into results. Also, let's declare that. Okay. So this is the case. Found is equal to 1. Oh, that's not the right syntax. And then now, same thing for the other ones. This is way more wordier than in Python, but maybe not. I don't know if this is right though, the diagonal one. Should be. I always forget whether it could be off. Because let's say we have 1 at 1 1, then it goes at 2 2, and then okay, so all the 1 to 0. But then what about the other diagonal? The other diagonal will be they sum to the same thing, right? Because at 1 1 it goes to 2 0 and 0 2. Okay, I think so. Okay, and then what's it called? All that pushback found. So then in theory you're done if the problem didn't require it feels that way a little bit. Yeah, Sudoku. But yeah, now we have to whatchamacallit? 1 0. Yeah, I mean we should do 1 1 is what the expected wrong answer is. Let's at least get that. Oh no. Where's query? Query. Do I do a set elevator? Did I have a typo or something? This is one of those things where I had to do this. Oops. Because queries is a vector. No, that's okay. I'll check real quick. I mean, if I get other errors, I'll get other errors. No. Auto hides some stuff. That's why I'm a little. Sometimes I've been getting better at using them, but not really. Huh? Type. Why is this a bull? Did I? Oh, I just have a double paren. That's why. Okay, that's silly. Okay. Okay, so this gives us the expected wrong answer. So now what we want to do is turn off lamps, right? So for that, we have to. So do we remove all 8 of them? That's not bad. I mean, we just put them in a hash table and then we remove all the diagonals when we remove and the. I think the tricky thing is now, well, now we just, I guess maybe that is something that we have to plan a little bit ahead, is that now, so I got pinged and it was really loud. Okay, so actually, I mean, it's the same, but what I have to do is convert this set into well, like a hash table, which is a map. I mean, it's not a map, actually. A map is ordered in C++, so it's actually a tree map. And that's what we want anyway, but I but it's kind of like that so that we can keep track of something like that. So then when we remove, we can keep track. Because the case that I was worried about is like if you have, say, two lamps on the same vertical, you don't, when you remove one, you don't want to remove the other one by accident, right? So yeah. And also we need to check, well, I guess this is still the same function for now. So let's see if that's still not die. Hey, thanks for the follow, infinitely M. Just missed something something. There we go. I think one thing before I do that though, I want to check that I'm checking the diagonals correct. Just because these things you never knew. You never knew. Actually, I guess 1 1 checks that, right? So okay, so maybe that's fine. And also 1 still checks the thing. Let's also check 2 2 just for sakes. So it should still give me 2 trues. 2 true. 2 true. Cool. Yeah, so actually I just expected everything because we didn't remove any. But yeah, but now that we did that, now we can start removing stuff, and we actually want to put the coordinates. So we have to do 8 each. Well, that's like 160,000. I always missed read these, so that's fine. So because you only have to look at the 8 direction, you just put them in the hash table and then we move them when we're ready. Yeah, so let's do that. Do we have lamps in the same place? Yes, that's an edge case. I guess. I guess it doesn't matter if we have them in the same place, except for that this may end up weird. Because then we have to remove it in the same place. It's annoying, but okay, fine. I can handle that case. So now we have a pair of intents for coordinates and map that into an int for let's say lamp coordinates. Yeah, let's do that. And then where we lamp, let's lamp coordinates that I guess we could just do make pair of lamp sub 0, lamp sub 1, and then just increment that. Okay, so now for every query we do all this funky stuff, and now let's just say if found. Yeah, so we only, I mean, this, I don't know if this is a necessary optimization per se, but it's a slight optimization in any case. So maybe if I was on, if I was doing like a time-sensitive competition, I might not add this unless I'm forced to for whatever reason. But the only reason why this is, you only check if it's found is because if it's in one of the directions, if it's in one of your 8 adjacent locations, then that means, or if it's not in one of, if you're in a place that's not lit, that means by induction, I guess, there's none in the 8 adjacent squares next to you. So a slight optimization, but maybe, which is always helpful. So if found, let's just say if not found, continue. So then we keep the nesting in a good level, at least if you get your parentheses correctly. And then now we do that fancy 8-directional dxdy trick. But you could just do for loops, really. A little weird the way I did it, but Okay. And then now we could do something like for, I call it K just because it's always how I done it. It's not just for consistent sakes. Uh, and then now, let's just say we're given ny. I still try to declare everything in the beginning, other than autos, because I don't know, it's just me. I still try to follow the C style of yeah, declaring everything in the beginning. But okay, so let's just say your new x is equal to the dx of k plus your current x, which is the query of 0, and then similarly do this. And then now we just check to see if it's within bounds. Let's say if this is the case, is it equal to? Yep, no. Oh no, this is Python syntax. Got too used to that part. So something like this. If this is within bounds, check to see if lam coordinates. I know it's not any whatever, but name coordinates. If we could find a make pair of ny, it's, let's say we find it, and the reason, yeah, if we found it, then let's just do let's just say current count is equal to the lam coordinates of this make pair. Okay, fine. That, and then we want to remove it. So let's just do. How do you move them? Okay, but now we want to remove it from vertical, horizontal, and diagonal as well. Yeah. So now vertical dot find of yeah, nx in this case. It should definitely be in there, really. So if not, then we have more issues. So we shouldn't need to check for this. But let's do that. If I don't know if we need to erase. Well, we do, because then we have to change some of these a little bit, and we rather not for slight performance issues. Let's say if it's 0, then we remove nx. And then we do the same for horizontal. There is definitely opportunity for code reuse, but well, oops, the other diagonal. So close to done, hopefully. A lot of typing, actually. For me, that's just the way I did it. Alright, so now we erase them so that hopefully the second time around it shouldn't call. It should not change the input that we have because we modify it slightly. Now we want to change it back to yeah, let's change that back to was it 1-0? That's unfortunate. Yeah, I was hoping that would work. Yeah. Let's just print out some debugging. Maybe I have some weird things here. This time I'm okay. Maybe. Even though I wrote it in a weird way. Usually I write it in a consistently symmetric way. Why does it take so long to charge? Okay, so I do remove the lamp, but but I don't do I have any typos or anything? But I guess I don't erase for whatever reason. And the one that we want to erase is horizontal or vertical. Unless I made a mistake somewhere. Yeah, let's take a look real quick at the count. I mean, there are a lot of typing, and that's the thing with these typing is that there are a lot of potential for silly mistakes. But did I get that? Let me double check real quick that I used the right case because I definitely once have, unfortunately, yeah, 0, 1. Or 1, 0, sorry. So 1, 0 is this one. At least that's right. At least my intentions are right. But the question is then, does alright, well, let's kind of look it up real quick. Okay. Well, that is a lot of typing. Maybe I should use the debug thing, but I feel like the Leetcode today is a little bit on the slow side, so it'll be a little bit annoying to kind of do it one by one. That's just my to walk step by step. Would be also be helpful though if I spell things correctly. Okay, I mean this seems right. We expect 1, 1, 1, 2 in the diagonal, and then 1 in the other diagonal, which actually doesn't really show up. I am just silly actually, because I don't reset file. That's kind of actually a silly bug. I guess that is the one thing that comes from C that I wouldn't have happened in other languages, just because if you declare a thingy there, then it would have been good. Okay. Let's try again on the other one then. Where was it? Let's try 1, 1 again, and then 2, 2 for funsies. And both of these should be true still. And then maybe we can remove another one, like 3, 3, and then 3, 3 to remove. Okay. I think right now I'm just little bit thinking about performance, but with n is equal to 20,000, we do mostly linear stuff. I mean, okay, log n if you count all the set stuffs, but it should be okay, knock on wood. Cool. All right, let's submit it real quick. Maybe I have some boundary. We'll see. Oh, no. Okay. Output 111, but it's 110. So 0, 0, 0, 4. This one turns out one of them. This turns out the other one. So why is this still on? Dong dong dong. Mystery. That was a silly mistake, actually. Yeah, okay, let's point this out real quick. So I think I expect to see a bunch of... Oh, this is on the thing. That's why I don't check to remove on the... I check to... I remove if it's next to it, but not on it. That's silly. That on this... I mean, the directions tell you. I'm being silly. Okay, fine. What is silly? I don't know. I think I just saw 8 and then I missed the first half of that sentence. Yeah, there we go. Okay, fine. Reading still the hardest part sometimes. Not all the time. A lot of times it's the other stuff. But reading is still a critical part. Oh no, I have another reading thing. Isn't this the input? Like the test case input? Maybe I missed something really silly. At least in terms of complexity, one's pretty okay. I just have to not make silly mistakes. Okay. So this one turns off this lamp, and this is literally the output, so why am I having issues? Or like the example case. Okay, the first one turns off lamp 00. It does a bunch of stuff. Alright. And then removes them, I assume. How do I test this? What did I fix again? Well, I fixed this, but... Oh, yeah, the movement was sitting on it, but that shouldn't affect anything. Oh, because then this is 9, so I'm... Oh, man. That's the fun part about using... Okay, well. So then just forget one of the directions. Well... yeah, I guess if I wasn't lazy, I would have tested more. But, oh no, please be kind. Okay, so just silly mistakes. Okay. Silly mistakes I can do. I mean, I think some of it I'm just a little tired and lazy, which is an honest thing. I mean, I just changed the array from 8 to 9, and I didn't change the for loop, which some of it is that I am a little bit used to Python, where you would range over the arrays instead of a hard-coded number. So definitely, and that same bug cost me twice, which is something I need to think about because definitely, even if it wasn't stayed out, like it is an edge case that I need to consider, and then just like look up to make sure, right? Like it's not a reasonable assumption without looking it up. That said, and I did it twice, so that if I was in a competition, it would have been 10 minutes worth of silliness. But yeah, but overall, not a very tough problem, but only if you have, I mean, I think this is a simple problem if you have a lot of just like learnings that have been done in maybe I'm phrasing that in a way, in a particular way. Max 0. Um, hmm, um, yeah, I mean, if I think also if I yeah, I mean there are a couple of ways. Like this could be just two for loops, right? Like I do it this way if they're like weird conditions, um, but yeah. Uh, But anyway, yeah. So overall, this is an easy problem, quote unquote easy, if you already have the foundation for it. There are a lot of things that is a prereq for this stuff. I think I talked to a friend of mine recently about not this problem, because I haven't seen this, but a similar kind of grid E problem where there's just grid um, it's just grid properties that you kind of get used to, but because you've seen a lot of grid problems. And definitely, I don't know how I feel about that for um, I don't know how I feel about that for interviews for someone like this, because like I wouldn't necessarily recommend people to practice a lot of grid problems, because from that grid problems, so how long did I end up taking? Wow, I took half an hour in this one. Did I just talk a lot? I guess I talked a bit, but oh, and I did try to use different languages and so forth. But wow, that's longer than I would have expected. But I did switch to C++, and I was kind of talking through it a little bit. Um, and also, I didn't think ahead too much. But yeah, but I think the thing that I mean, the vertical and horizontal, I think this is relatively straightforward to think about. But in that same way, where like someone could be like, okay, yeah, you just do a hash table or a lookup table or a tree map thing on the x coordinates because that's the vertical. You have a lot of experience with kind of dealing with the diagonals. These things would come natural to you, right? So that's the type of stuff that you get only from practice and thinking through a problem really deeply. But but in terms of interviewing, like I don't know if this is worth that effort to kind of know these things, because after that, like all these is relatively straightforward, and this is just a regular like two for loops. Oops, what did I do? And then erasing them and keeping track that way, and everything is in O of log n. So this is n log n, or well, n log n for building the pre-processing, and then for each query is log n. Uh, yeah, so it's n log n plus n log, oh sorry, q log n or something like that. So q n plus q times log n. So yeah, that's kind of the situation here. So for interviews, I would definitely not worry about it that much. For in the sense that like I think there are way more things you could spend your time better than learning about grid problems that probably will even less have a real life equivalent, unless you like to play chess or something, which is fine. But then you maybe already know how to do half of these things uh, if you explore chess problems. But for competitive programming, I think this is relatively standard way of doing to kind of hash both vertical and horizontal, but also the diagonals. Though it was a little bit of time for me, so I had to remember it a little bit as well. Um, but yeah, cool. That's all I have to say about this problem. Also, yeah, it's n plus q log n. Yeah, cool.